Eh, jo, takhle není ten. Počkej, ty chceš jako livestreamovat? Už to Jo, dobře, dobře, dobře. So, hello, I think we are ready to start. So if you can finish your beers and finish your pizzas, find a seat. To je kvůli... To vlastně musím vůbec říct. Ještě jednou.
Bude to na záznam.
So, welcome to the next CocoaHeads event. I would like to thank the organizers today, which is Applifting, so please, give a nice round of applause to them. So I see you've already found a beer, you already found a pizza. So I think we are ready to start with the first talk for today. And it's Philip from Applifting, so it's the local guide, and he will tell us some interesting things about Combine.
Thanks, guys. Hey, everyone. Pleasure to meet you and pleasure to see you here today. I was asked to talk about Combine, and that I will do. So, first, who of you did work with Combine yet? Is there anyone who worked with Combine? Well, I see one person there. Nobody else? Okay, great. So how many of you did work with reactive programming already? Quite a plenty of hands, that's great. So first I'll do a short intro to reactive programming, and then we can see how it applies to Combine framework, and yeah, that's about it. So, first, we have asynchronous operations. That's like a basic cornerstone of programming right now, because most of what we do, we don't do in the foreground, but we do it on the background to don't block the user interface, and to enable the user to work with the interface even if the app is processing in the background. And there are like multiple ways how to approach asynchronous operations right now. And those are, for example, callbacks or key value observation, which is like very Apple specific thing. Then we have notifications, notification center, and for example, closures. And so what's reactive programming? Reactive programming is something which is an abstraction for typical asynchronous operations. And the way it works is we have something which is called a publisher, and the publisher is a box which creates events, right? And then we have a subscriber, which is connected to that publisher and is receiving those events. But we still can't really do anything with just like two pieces connected together, and we need to work with what the events are and how does the application work around those events. And that's why we have operators. So this is the basic structure of how it works. So we have different operators. We can, for example, like filter out different signals, different events, or we can map those events to different kinds of events. That sounds really abstract, right? So let's see how it works in real life. This is a generic screen which has one text field and one button, and we see that as the text field is empty, the button is disabled. And how this works is that we have like text field text, which is what we call the publisher, and it creates events each time user enters the text. And then we have button is enabled, which is the subscriber, which updates in accordance to what goes inside. But in between, we need to do some operations, and like the most basic operations would be like, is there something in text field? More advanced operation would be, for example, is the phone number valid? So this is basically what's reactive programming all about. Congratulations, now you know how to think in React programming. So what's Combine about? What's Combine? Does everybody know what's Combine? This is Combine. It's a combine harvester, to be exact. And yeah, so Combine has publishers, as I shown you, and publisher is something which creates events and sends them to subscribers. Important thing about publishers in Combine is that they can end the stream, and they have two associated types, which is quite important thing. And one of them is value. It's the kind of event that's floating from the publisher, and it has a failure type. And you can choose whether you want to have a failure type, which is, for example, some error, or you can say that it can never fail, and then the failure type would be never, which is a new type which you might be already familiar with. So example here, if we, for example, would download products, then our value would be array of those products, while the failure type would be a download error. If we would have a different publisher, which would be, for example, sorry? While the failure type would be a download error. I think someone's listening to the stream. The stream was through the speakers, so don't do that, please. Anyway, if we would have a publisher for a text field, which we already seen in the example before, then the associated type for value would be a string, because it sends strings, but it can never fail. It can't tell us like, I failed, the pipe is broken. Another example would be user profile. And user profile can send, again, values, and the values can be optionals, and it might never fail, right? So it's important to think about publishers that have associated types, and there are always two associated types. One for the value and one for the failure. Okay, so what if we take a publisher and connect it to a subscriber? We get something which is called cancelable. And cancelable is one of the most important concepts of Combine. And it's the pipe we create, if we put those two together. And the event stream starts not when we create the publisher, not when we create the observer, but when we connect them together. And why is it called cancelable? It's called cancelable because you can explicitly cancel it by calling cancel method. But also, important part is that the cancel is called also when the object is auto-released. So basically, you can use this to manage your memory. What does it mean really in practice is that you still need to keep the reference to the pipe you create, because if you don't keep the reference, the pipe closes immediately. For example, if you would create a new pipe in a new cancelable in view.load, and you wouldn't retain the reference in the instance, it would go out of memory as soon as the view.load would end. Right. So how can we make cancelables? So for example, if we have like some publisher, then like the easiest cancelable we can create is just like .assign, and .assign is a subscriber which takes an instance and a type safe path, and then saves the events to that instance. It's pretty easy. And another useful one is sync. And the sync does basically the same thing, but you can really do something with the object you get or the event you get. So for example, this one does stuff with username that's passed into the closure that's given as an argument. So the third and perhaps most important part of reactive programming are the operators. And operators work on the event stream that's passed between the producer and the subscriber. And important thing is that they create new publishers. So if you take publisher and an operator, together they create a new publisher. So they can encapsulate them, and they can be chained and combined. So for example, if you have operator here, you can have two operators, for example. So why is it called combine? Does anyone know? No? Because it's reaping, threshing, and winnowing. That's something I learned recently. I didn't expect anyone to know that. And so this is why it's combine. Because you have wheat on one side, and then you reap those wheats, then you thresh those wheats, which means basically you just like loosen the seeds. And the winnowing is like getting the seeds out of those, well, long things. And here we have seeds. And the combination of those operators is basically what's happening here. And combination of operators is the most important thing you need to think about when you are thinking about how to create a app using combine. Because this is how many operators there are. And this is not all of them. This is like a reasonable amount of operators. And what Apple says is like, we have this many operators because they are really simple. Each of them is really, really simple. And we don't have like few highly specialized operators that do a lot of stuff. We have a huge amount of operators, and each of them does a really, really small thing. And you need to think about something called composition. And you really need to think about how to create your app in a way that you need to think about how the data flows through the app, how the data changes through the app. And we'll see about that in a second. First, I'll tell you about something more about the operators themselves. So, if we want to process the events in the stream, then we have, for example, map. Map basically does what it says. It takes a stream of events and transfers them to some different event. For example, if we would have a username stream, we'd call this. We would get a, sorry, did I say username stream? I meant user stream, and I would call this. I would get a stream which has usernames. Then we have compact map. Fun thing about operator names is that they are pretty much analogous to operators on arrays. So typically, if we have map, it filters the events and changes them, no, sorry, not filters, but changes the events into some other events. If we have compact map, it changes those events, and if the result of the closure is nil, then it filters those events out. Then we have, for example, filter, which does pretty much what it says. We have prefix, which is again something which we would expect on an array, but wouldn't expect on, let's say, event stream. And what it does is it sends only the first 3 events from the stream and then cancels the stream. And then we have debounce. Debounce is an interesting one because it doesn't just work with events, it works with time. It works in a way that if you have fast stream of events, then you don't always want to propagate all of them. Sometimes you just want to propagate the events if nothing happens for a certain period of time. Let's say, for example, if you had a username field and you wanted each time a user changes the text that's there to send a request and check whether the username is available. So what this operator does is I'll wait until there isn't a change for 0.5 seconds, and then I'll send the event. So it's like really advanced logic, but done in a really, really simple way. This one's my favorite. What this operator does is it's a decoder. It's a decoder in one simple call, and you can use it to, if of course the user profile is JSON decodable, then you can just pass the stream of data into this and get stream of user profiles out of it. So this is really awesome. Then we have something which is called joining of streams. Because sometimes you need to work with multiple streams, not just one stream. You need to like take data from different places around the app and take them together. So for this, we have, for example, zip. What zip does is it takes event from one place and takes the event from second place and combines them together. If second event comes from this place too, if second event comes, it waits until all of the other places have a new event and takes them together and sends a new signal. Combine latest is something like zip, but not quite. Because what it does is that each time there is a new event on one of the streams it's connected to, it sends a new event with the latest values from all the streams. You'll see about that in a moment. Then we have error handling. Like error handling is really, really important, and everybody knows about that. Nobody does it. We have assert no failure, which is a beautiful operator. What it does is that you do you remember how we talked about that there are two associated values for each stream? That you have like the value and the failure type. What this event does, what this operator does, is that if you take a source of events and then assert no failure, it changes the error type to never. Sadly, if it fails, then it breaks the app, but well. Then we have catch. Catch is more reasonable. Catch allows you to actually do some logic if something fails. Then we have replace error, which is really useful because it gets called when there is an error, and if there is an error, you can replace it with a useful value, for example, 0, something that's reasonable for your app. Or retry. Retry is especially interesting one because it doesn't just work with the downstream, it works also upstream. It forces the source to generate a new event. And then we have some special operators. Special. One of them is flat map. What flat map does is quite interesting, and I'll get back to it in a bit. We have receive. Receive just changes the thread that the operations are going on, which is especially useful when you are doing something in the background and want to switch to the foreground, or vice versa. And there we have a more interesting example. So here we have like some ticker, some segmented control, and 2 input fields, and again, a button. And what happens is we have some publishers, the value of the picker, the selector of the gender, the 2 text fields, and we have a subscriber, which is the enableness of the button. And let's talk about the composition again. So how should we make this work? So if we have the age picker value, then we want to perhaps have a filter there to see if there are perhaps people who are underage for the use of our services. Then, when we have gender selector, we need to use something like compact map because it filters out the nil values. Then we have the male text field, and there's a filter and debounds. I'm not sure what is debounds because it shouldn't be there. There should be just like filter, right? And it filters out when the email is not really an email, for example. And right here we have nick text field, which is interesting because we have the filter, which is reasonable to have. Like, for example, we wait until we have at least 3 characters to do additional logic. But then we have the bounds, and we wait half a second when user is not entering anything. And then we use flat map. Why we need to use flat map is because here we call an additional stream which gets us availability of the nick from the server. And this is not something which is linear. We can't really just like put a different stream inside a stream because then it will be inside a stream. And what flat map does is wait until this stream finishes, then unwrap the value and pass it inside. So this is like, the flat map is a real elegant way how to like put streams inside of your streams. For example, you can think about it as if you have a closure, and inside the closure you call a different closure, then you wouldn't get the result inside of that closure, but you would get it on one level plus. So this is what flat map does. It unwraps the stream. Then we would use something like combine latest to get like the latest event from all of those. And when we get something, we can decide whether we should enable or disable the button. And this is a scheme which is like really important because each time you design a screen or design a process with combine, it's really important to think about like not just what it should do, but how the data should flow through the application. Right, so now you know how to use combine as well. Any questions?
I have one.
Sure.
Do you use combine in production?
Not yet. We are using different reactive programming technologies, but we are really looking forward to it. Most of our projects don't support iOS 13 exclusively, so that's the main reason why not. But I think as most of our customers are quite progressive, we'll be forced to use it eventually. Same as Swift UI and the new stuff like that. And I think it will make our lives like much easier. So we are preparing for it right now. And this is one of the reasons why I did have the speak, because, well, I had the same thing for my colleagues here. So,
okay. I have one more question.
Sure.
I have some articles about the combine.
Yeah.
And I see that combine is really fast, even faster than reactive Swift, and also it consumes less memory.
Mm-hmm.
And my question, are you planning in the future maybe rewrite some part of your apps for the using combine or not?
Yeah, I think I can safely assume that we will rewrite part of, or a significant part of our applications to combine. And it's mostly because it's much more legible than the technologies we are currently using. And yeah, the performance also might play a part, but I'm not entirely sure about that.
Thank you.
Thanks. Any other questions? Sure.
Do you feel combine is, or is there anything missing in combine if you compare it to RX Swift or reactive Swift?
Yeah. I didn't find anything missing already. Maybe the concept of dispose bags works differently because right now it's auto-managed from ARC. And it's maybe something to like get used to and not something that's missing. And I really didn't see anything like missing per se. Maybe if there were like some more complicated things, then the compiler might fail. But I'm not entirely sure about that. There was occurrences when my compiler failed with segmentation fault when I was working with RX Swift, but it didn't happen so far with Combine. But I didn't really do like much advanced things. Anyone else? Sure, in the back.
Are there any
Sorry? Any and debugging tools? I don't think so. I haven't met any specific debugging tools for this. There are some debugging operators, like operators which are specifically designed for debugging, for example, print. So that says a lot, but no, I don't think so. Sorry, in the total back.
I had a similar question.
Sure.
You ever tried to debug any code using Combine, especially code coming from somebody else than you?
No, but I did try to debug a RX Swift, which is terrible and it's nightmare, and I wouldn't recommend it to anyone. But still, if the code is written properly, then you would know what it does, but still debugging someone else's code is painful. That will never change, and I don't think that Combine changes anything about that. It's just like you have to have the different approach to debugging when you are using reactive programming. And in the back?
My question basically was the same for two guys before.
Okay, so is it answered or? Is it answered or?
Yes, probably yes, but
Okay.
my experience with Red Swift was that you use debug mostly because you don't have much choice. You have to understand. And is it the same in Combine basically? Is it like you need is it you limited only on print or you can do something more? Or like it's the same?
I don't think so, but I'll need to check because there were guys in the company who worked much more with RX Swift than me, but I don't think there was any specific tools. So, and any specific tools for Combine as well. Yes, in back.
Actually, two questions. First, how this works in the broader architecture in terms of controllers or the new React kind of programming in all of the views in iOS. So how do you structure a code in Combine so it doesn't end up in let's say one huge pie of producers and consumers?
Right. So most sane place to have the logic, like the operator logic and all the pipes, is to have it in view model if you are using the MVVM design practice. I wouldn't really know where to recommend having it if you are using MVC, because I wouldn't really know what to recommend to you generally. But yeah, I think the view controllers make most sense. Perhaps some controllers if you are using different architecture. Anyone else?
Can you confirm that there is missing the part related to the UI kit? I mean, this is compared to RX Swift. This is equivalent of RX Swift, but it's missing RX Cocoa.
You mean like if there is something like
No
RX Cocoa?
No UI kit publishers.
Like
no, actually there are publishers, and it's quite easy to.
They are?
Yes.
like reactive API upload like it, so
Yeah.
you can go to the next field.
I'm not 100% sure if they were there from the start, but right now, yeah, you can.
I heard that it's missing. If not, it's even better.
I don't think so. Like it's really easy to do, and it's really easy to like add to existing code. Like if you want to create a publisher from variable, then you just like published as a modifier word, and then you can by ampersand reference it as a publisher, and then each time anyone writes.
How do I subscribe to TextView or button?
They have each separate publishers. So I think there is a publishers library which has all the publishers for the UI kit, but I'm not 100% sure, and I'll need to check, but I'll get back to you in a few minutes. Anyone else?
So
Yes, sure.
if you were starting an app, the new app today was iOS 13 plus, you would use Combine definitely?
That's a great question. I would say yes for some parts of the application, and I'm not entirely sure if I would do all logic in Combine. because I'm still not confident enough that this won't go bad in the way that most older RX projects went. So I would like to contain it somewhere. Is that all? Perfect.
Okay, great. Thank you very much. So we will have just like 5 minutes break. We just set it up everything here. So get here, go to the toilet, and then we will continue. Okay, ladies and gentlemen, we are ready for the next talk. This one is from Dennis. I know him for
5 minutes, no,
for
20,
like,
20,
I don't
20,
know.
20.
Yeah, but for like 2 years as a man with bear. And only today I found out he's also called Dennis. And he will tell us something about XC test and its runtime and how to hack it.
Little bit. So hello everybody. First note, feel free to ask any questions, say that here's some bullshit on slides. Like, feel free. Don't wait till the ending. Here no section for questions in the ending. And in my presentation here will be a huge amount of screenshots of code. Be ready. But it's okay, we all here are developers. We like code, hate people, like classic. Yep. So one day I wake up and like look at the window, mirror, and like, Dennis, you're 24 years old. What are you doing with your life? Like, you're only consuming and not giving anything back to society. Let's do something with that. From that point, I decided each day I will be doing something for people daily from what I'm good at, probably programming. At least I think so. Okay? So I create account on Stack Overflow. Easy peasy. And for like week, 2 weeks, I was trying to help people answer their questions. And I did questions, moderating, which fun thing. Here you can see how I get reputation each day. And by the way, this 200 line, it's like daily limit. And what can I say about it? It's fucking hard. It's really hard work. Like, you need to understand what they're asking you for, find it because you don't know everything, yeah? So you need to just Google it. Find someone else answer, like say that it's duplicate and etc. But it's not about it, okay? So now you're like asking, what it's do is Xcode test and etc. Yep. So here it's coming. Boom. You don't need to read it. Basically, this person asking that he has one function and different parameters for it. So he wants to run tests for each pair of parameter and result, and wanted to have like different tests because you don't want one test to fail because of 25 reasons. Yeah. So I'm like, no, not this one. Like, yeah, like, let's do it. Like, why not? I don't have any idea how to do it, and Google, my friend. So one note, this will be about Xcode tests which comes with Xcode, not one which open source on GitHub. They have like big difference under hood, like Swift version don't use Objective-C runtime, so here not big magic here. Yep. So, OC unit. Is here anyone dinosaur who remember what this OC unit is? No? No one? Even I don't remember. Basically, OC unit is father of XC test, which was main testing framework before Xcode 5, I think. And what I can say? Xcode test most simplest and easiest framework from all I have seen so far from Apple, most likely because it haven't been written by Apple. Yeah. So we will go and check out source code of OC unit because it's open sourced and you can find it on their website or my GitHub. I copied it. Yeah. So next one. Basically, all you need to know about OC test, Xcode test, or OC unit, doesn't matter. You have two main workers, send test case, all know what is it, Xcode test case, you use it, yep. Send test suite, okay, XZ test suite. Anyone know what this test suite is? Any question? No? Okay, super. Basically, test suite is bundle of test cases. Every one you create project, put test in that, here will be one huge Xcode test suite unless you do something different. Yep. And here like 5, 6 more classes which is not exist in anymore and don't important for us. So brace yourself. You don't need to read it code. It's here just because you don't believe me. Yep. I wouldn't believe me. So here are some proofs. First of all, what Xcode test doing? We take all send-test Xcode test case childs and get all their functions. Yep. For all send-test case uses, we take all test invocations, magic word, remember it. And for each test invocation, we create new test in runtime. What is test invocation? Basically, Objective-C runtime, get all methods. If method has test signature, which is start with test, return void, and has no parameters. Easy peasy. So now you know how work Xcode test, yep? And we know what to do. We have a plan. We'll first create our subclass because we need it. We create some magic properties which we will override and then provide tests in runtime, map this test in some invocation, and important note, we need to not forget about adding in them as methods to our class, otherwise it will be not working. Yep. So, who knows what an NS invocation is? I see 1, 2 guys, like. No. Okay, let's go to documentation. Boom. As you can see, NS invocation is basically encapsulation of call of function on some object. That's it. Basically, you can just write object, perform something, or create an NS invocation. Here are some benefits, not important. Who can find what's wrong on this slide? I give like 2-3 minutes. Anyone? Any ideas? Okay. Anyone else? Okay, go.
It's Objective-C only.
Yeah, as you can see, it's Objective-C, and language selector doesn't work. Like, you can select Swift. Long story short, you can't use an NS invocation in Swift. Like, it doesn't work at all. Like, I'm lying right now. Yep, you can use an NS invocation. I not recommend to. Like, really, like, NS class from string class method. No, like, not our approach. We have plan 2. We will use Objective-C, like, why not? I love Objective-C, like, if you don't know, yep. I use Swift, but Objective-C was cool. So, we create DP test case. Look at this prefix here. We want to hide it because our colleagues' mental health is important. Like, no one need to know. It yourself have some necessary of selectors. We will pass them here. You see this? You can pass selector in necessary Swift Objective-C magic. So we will create some wrapper around it. After that, we provide some methods, create Swift normal class, provide a P, boom, we're ready. So let's go. First one, easy peasy, some wrapper around selector, declaration, it's Objective-C if you don't remember. Second one, third one, we already did first, second. Get all methods from our magic method, create invocation. It's way easier than the Swift, you know? Yeah? And it's done. Now Swift part. Because we hate tuples, all hate tuples, we create some structure here, because it has name, properties, nice. And to hide internal logic, we have second method. And some Objective-C is fair. Not a problem. And done. We can do our tests like that, like create some tests, map them, create runtime tests. It's working. With superheroes, answer accepted, I got my reputation, I got bounty, like super. And this is not everything. In our company, we're doing snapshot tests. There's this nice feature when you write tests, which you open your application, do some screenshots, save it, and then compare it. And second, code style, I can say, we put in most of our components, which view related, which have some state, put some enum or struct state because it's awesome. And our snapshot test looks like we mock everything, create component, pass state, make snapshot. And for most cases, it looks like the same. You just copy paste most of stuff. We can generate it, like why not, yeah? So stateful component snapshot test case was created. Basically, same stuff, component test, which is map everything, and here how we use it. We have same test, which writes something like what this test doing, name of test, and some state for our component. And here factory how to create it. And nice, yeah? But everyone liked it in my company. They say like, awesome, Dennis, cool, we like it. Not really like it. Main answer was like, why we need it. But I really hate this syntax, like, why I need to write this parentheses, this commas, nah, not my style. So what we're doing next? Function builder. This new super feature from Swift 5.1, new feature, yep. For people who doesn't know, it's not released yet. Because of it, you have such underscore here. But we will use it, we cool guys, yep. And for people who doesn't know what function builder is it's basically a way how to call your function if you're lazy to write commas. So it's like my use case. This is how you created it. If you will try to find documentation, I recommended it. It's awesome. Like, really cool documentation. Like, I liked it. I understand almost everything. Problem is, it doesn't work like that. Like, I can say it's problem because it's not released yet. Like, some part of it works, so like, okay. But don't try to find why some build, not block, but build some other stuff don't work because it's not ready, basically. They need to do it as fast as possible for Swift UI, yeah? So, boom. Test, state, I just put here line empty because I like it. Other name, other state. And this is how it's done. You will say like, yeah, nice magic stuff. Show me real work, yep. Boom. It's our code from our project. Like I just make screenshot almost right now. And we create factory, mock everything, all dependencies, mock all singletons, create it, and here for our tests. Handy, yep. This is how it works in.
Yeah, famous.
In Xcode, you will see it like that. Actually, I was pretty impressed when I found that I can name my test with white spaces and basically whatever I want to put here. I don't know why it doesn't work before. I found in Quick, someone know what Quick is? You know everything, stop it. Basically, Quick is a BDD framework, which allows you to write some new syntax for your tests. And they do basically same shit. I just copied it from them like half of my code. And they put underscore between your words, remove all forbidden ones. I even create issue on GitHub, like asking guys, why are you doing it? No one answered me, except one cool guy who helped me find first time it appeared in their code base. It just appeared, no questions why they did it. And probably everyone saw it, happy user feedback. So our company liked it. And about our company, I'm from Showmax. Actually, Showmax sponsored this talk. They literally pay me to do it in my work time. Probably someone from you was on my previous talk year before on Swift in Prague. I show you some nice statistic about our project here. And after 1 year, we just lost 20,000 of lines of code. And if you want to work with such cool guy as I am, or like Dominic or Robin, feel free to talk with me or like. So that's everything. You can find example of this, not example, just code from presentation on GitHub. You can find me on like whatever when with beer. On our blog, we write some cool stuff about some backend, about some CD. I don't understand this stuff, but people say that it's awesome. Sometimes we even put IO stuff here, so check it out. And I'm done. Go for it.
How much time did you spend on figuring out how to add this like a runtime test to XC test case?
2 hours. And after that, I spent like, I don't know, 20 hours to making this presentation. Actually, no, it's like was pretty easy, except this Swift Objective-C stuff. And I spent 10 more hours trying to do more magic, which you can find here. I don't show you because we haven't found really usage for it so far. In 2 words, you take whatever method you have with some prefix and add some additional behavior to it. Like, let's say you have methods which starts like duck whatever, and it will print out quack after test. It's just example. We could do snapshot with it, but so far no one did it, so I can't say anything about it. No? Any questions?
I have a question.
Go for it.
Yeah, so today I was writing some snapshot test on this, and somehow the setup from the XC test class didn't call. Because of somehow, I don't know, the implementation.
I know why. You fuck up something.
Okay.
Oh, actually, like, you need to look at stack trace and find what's going on. But most likely it should work, and it worked before, so like, you know.
Okay.
So I'm done.
Okay.
Oh, sorry. Go for it.
Is there any reason that we shouldn't be using the snap project?
Why you should use it in your project?
And add it to my project tomorrow? Because this is super cool.
Why? Why you would use it?
It's cool, fast, sometimes doesn't work because of the syntax sugar, but
Yeah, actually,
anyway, it's like right, and I really like it, like from the user perspective, I really love it. You can just simple create a view control. And from the snapshot point of view, you just create a view controller, make the test, and it's ready. As you see from this like stuff, I just created view controller and added some wrapper around the state and transiting from the state to another with just simply putting the state, which is it in the string, and then just put it. I think it's like super cool way. Anyways.
I would say we doing it because I was bored. It's
That's most of this time.
yeah, it's main idea. And second one, like, I like how it looks. It's remove little bit of boilerplate, but if we will be fair with one another, it's not huge deal. Yep. I just saying you that I found some funny stuff and talking about it.
Yeah, I also think that it's quite safe because the quick testing framework, it uses this kind of shit like for like 5 years. So.
And it's like a real way how you should do it. It's written in documentation, basically. So I sold it, yeah? Also.
Not the function builder stuff. That's crazy.
Actually, I'm waiting for function builders to be, where's function? I'm waiting for function builders to be production ready. So in test, you can do whatever you want because it's test, yeah? We even use some explicitly unwrapped optionals.
Wow.
Yeah. That's it.
I have a question. At the start of your presentation, you tell once upon a time, so blah blah blah. And now, are you satisfied what you are doing for the society or not?
Have you watched Mr. Robot? Okay. I would say I'm pretty satisfied now. I'm giving talks to people. Yep. I'm sometimes trying to write blog posts. I even have blog. You can find it on my GitHub. You can look at source codes because it doesn't work for some reason. In general, I would like to get back to Stack Overflow because I liked it in terms I learned a lot. Not like how do my daily job because like my daily job I'm doing like 5 years, yeah. But some stuff that's not appear in your job. Like, for example, I found why zero in why nil integer in Swift equal to null in Objective-C, such stuff, which just will not help you, but it's just awesome to know. Yep. So, I'm done.
All right, so let's have a longer break now, like 15 minutes, and then we will have the final talk. Cool.
Get back. Turn off. Tak. Děkuji. Teď to
Protože já jsem koukal na Quick, převádní máš 4. A já jsem tam našel a já jsem říkal, to bylo zajímavý to.
Yeah. Ja, takže good. Mám to malý? Jo. To je možný. Tak jsem nechtěl začít takhle.
Žádný big topic.
Tak už je. Good. Hello. Good.
Okay, ladies and gentlemen, we are ready for the final talk. All right, so the final talk for tonight, it's from Marek, from Eki, and I'm personally super happy about this talk because I remember the tweet where he announced it, and I was super excited about the tweet. So I hope he will tell us more about the tool I'm that excited about. So give it up for Marek.
All right, so hello everybody. My name is Mark Fort, as he already said, and today's talk is going to be about building Swift command line interfaces. And the first part will be about a tool that I built, and then I will try to show you how you could build such tool yourself. And I was just wondering how many of you have tinkered with Swift command line interfaces, tried to work with them? All right, so not many? Yeah, okay, cool. So first a little about Techie. Probably a lot of you know about it, so I'll be quick. We were founded in 2012, and there's around 60 team members. And most of us are Czech Technical University graduates. Hopefully I will become one next year, so cross fingers for that. So Tapestry, that's a tool that I have been working on for the past 4 or 3 months. And now I'll tell you something about it. So what it does, it has 2 main components. First, it provides a framework template that's built around Swift Package Manager. So if you want to build a new open source tool, this is a great way to not think about how the files should be ordered, etc. And you can just use Tapestry for that. And it also provides a simple compatibility with CocoaPods or Carthage. And then it also helps you to ease your release process of your tool with automation, which means that you get to define the steps of your release process in a type-safe editable configuration file. I will get to it in a minute. And then you run a simple command, and it does all the steps for you. Also, a side note, a lot of concepts in this talk and in Tapestry have been inspired by Twist, which is an Xcode project generation tool. And I also recommend you to check it out. It's also really cool. So this is how you create a new tool. You go to empty directory, you run Tapestry init, then it asks for some basic info like your author name, so you can provide it in, for example, in the license file, or bundle ID that's then filled in the example project. Then it asks you if you want to create a library or executable. In this case, it was library. And if all goes well, your package is generated. Pretty simple. And then how you can release your tool. Side note, Tapestry is also released with Tapestry, so that's quite meta, and I really like to use it for that. And so the way you do it, you run Tapestry release, and then you provide the version that you want to release, and then it runs the steps that you have defined in the configuration file. So for this case, it updates your documentation. So for example, if you have in your README a version, the latest version, it updates that. Or if you provide compatibility with CocoaPods, then you need to have the .podspec file, and there you can. It also automatically updates that version, so you don't have to go through all of those files and change those versions by yourself. Then here it also checks that the project is CocoaPods compatible, Carthage compatible, and Swift Package Manager compatible. Sorry. And then it actually updates the version, which means that it commits the changes from the updating docs step and creates a new Git tag and pushes it to the Git remote repository. And now to the configuration file. This is how it looks. It's inspired by a package.swift file. It works in a similar way. So this is a normal .swift file, which means that you get all the benefits of using Swift language. So besides syntax highlighting, which is obvious one, you get a type safe code, and you also get auto completion. And with that comes that you also get the documentation of all these methods or all these enums, etc. You get this documentation right inside this file, because when you start typing release, for example, it will tell you that there's this structure available, and since the code is documented in the package description, which gets imported here, you get also all the documentation from that library. So I think it's pretty cool, and yeah. And so we implemented it, for example, for in the Twist organization. They also provide a tool for working with Xcode project file, and the tool is called Xcode Proj. I don't know if you know about it. It's also quite cool. And so the release steps got quite long and tedious, and for a newcomer, it was really frightening to see this and try to go through these steps, and there's a whole lot of stuff that can go wrong. And so when we introduced Tapestry, the list has become much more shorter, and well, hopefully these two last steps we will be able to cut those two in the future, but these are GitHub related and that's not implemented yet. And so now to the second part of the talk, which is how you could build such a tool yourself. So Swift Package Manager, well, it not only supports Swift Package Manager, but Swift Package Manager is open source, and so that means that you get to also use the libraries that they use internally for the project itself, and it has quite a lot of cool stuff that you can use for your command line interfaces. So why would you use those? Well, you get to eliminate a whole lot of dependencies because, well, you just import Swift package and you're done. Instead of, for example, if you want to work with absolute paths and relative paths, you have to have some dependency for that. Then if you want to create your own commands for the tool, you have to add another dependency for that, and it goes on, and usually most of the stuff is already implemented there, so you don't have to do anything, just import it and use it. And it's obviously also closely aligned with Apple standards, which makes sense. But that means that also the API of the tools that you use, or of the Swift Package Manager, they push you to write the code in like an Apple way. Minus is, as obviously, lack of documentation. So there is no like GitHub page that you can go through. Usually the only documentation is the documentation in the source code, or well, tutorials, but I don't count those. So now let's see how you could create your own command. So this is a command registry. It's a simple place that you can define all your commands in. You can define all of your commands in this one place, and there are basically only two main parts. Is the argument parser and the commands array. Both are from the Swift Package Manager. And then in the initializer of the command registry, we initialize the argument parser with the name and the usage. These are, we have to provide these values, and then we just register these two commands. We'll show you how to create the release command in just a minute. And we add them to this array with the parser that we have initialized here. And then when we run the command registry, we just process the arguments from the user. These are almost everything is also from the Swift package manager. And then from the parse arguments, we find by the name of the command, which is this dot command, we find which command we want to run, and we run it with the process arguments. And so this is how the release command can look like. It just has to conform to the commands protocol, which means that you have to provide the command name and the overview of the command, and it has to be able to be run with the arguments from the argument parser that you have just seen. And so the other stuff is optional, so you can define your own arguments. In this case, I want to have a positional argument, which means it's determined by its position. You can also have an option argument, which means that it doesn't depend on the position, but it depends on the prefix with double dash or dash, as you are probably familiar with working already. And it takes an input of version, which is actually also from the Swift package manager. And this means just that it takes as an input a string, which has a major, minor, and patch version. And it converts this string to a struct that you can then use in a type-safe way around your code base. And so we have this parser, and we just need to add the argument, and then we actually run it. We use this property, and we just get it, which means that it returns an optional. So we need to throw an error if it was nil, and then we can do all sorts of logic down there. And then in the main.swift file is a file that all the Swift executables are run from. Then we just initialize it and run it. And yeah, that's how you can implement your own command. And well, sometimes things go wrong. And it's, I think, more important in the CL, in the command line interfaces to treat the errors as first-class citizens than in the applications. And so I think there are a few guidelines that you should follow and that will make your CLI more reliable and better for your users. So I think that you should make your errors actionable. What I mean by that? Well, I mean that if an error occurs, the user should immediately know what his next step should be and what he should do with what went wrong. And if you don't know what went wrong and don't know what the next steps should be, you should at least provide enough information so you should be able to debug the problem. And then definitely make them part of your testing process. So make the test cases for them, test even for specific errors. I will show it a little bit later. And also it's a good thing to let errors, as you can say, bubble up and handle them in one place. So it's more easy to reason about the code. And also if you want to make for example, some custom printing of the error, you get to do it in this one place. And it's, yeah. So this is just revisiting command registry. Not much has changed. We only now handle the error and print it in this one place. And usually most errors should fall through this catch statement. And an error example, which I think is follows those guidelines, is when you run, for example, a Tapestry release, but the version already exists. So you obviously cannot release it again. So it tells you that the tag already exists, and then it tells you what your next steps should be. So you should either delete the tag or probably use a different one. And now a little bit about testability. I found the best the combination of dependency injection and then share dependencies for the most used ones and for those that don't hold any state. So that means that it's still easy to write new components because you don't have to import or import in the init all like system for interacting with the shell, etc. But you still get the flexibility of stubbing and mocking everything. And as I said, test for specific errors. So when you expect that something goes wrong in a certain way, you should test for it so you know that there are no regressions in this regard. Then I think you should wrap what you can. So for example, it might be tempting when importing some dependency for interacting with shell, just use those commands directly, but then you are dependent on the creator of the tool that they provide a good stubbing method. So, and it also makes your code less flexible in the long run. And you should strive to be in a state when writing tests is as fun as writing new functions. It probably will not be, but at least strive for that. So this is an example of how we interact with the shell in Tapestry or in Twist actually. So it's a simple wrapper around Swift package manager utilities process that handles everything, almost everything for us. We just provide it with the arguments, which is array of strings, and we run it and throw if error. So pretty simple stuff. And then we provide also a shared instance that we can have around the code base. And then we have a shared test case, so we ensure that we always get a clean slate before running each test, which I think is really important. So in here we define a mock system where we can easily stop error commands or successful commands, etc. And we always reinitialize it. And then when we test for a specific error, we get to touch the mock system we have defined just earlier. We stop the command using a simple convenient function, and we expect these three parameters to be run from this function. And so we stop it with an error. And then when we actually run it, we assert that a specific error has been thrown. That function is also a convenient function, but I think everybody can build it yourself, or you can look on GitHub, etc., or just ask me after the talk. And so if you made other options, this test could maybe be a little bit longer, but I think this way is quite easy to reason about, and it's quite readable, and it was actually fun to write. So just some takeaways from this talk. I recommend you to use Tapestry to automate your release process, obviously, but I mean, it has a broader message that you should probably strive to automate any tedious task that you encounter during your development. And then think about using Swift package manager libraries, because they have a lot of interesting stuff and can make your development quite easier in the long run. And definitely treat errors as a key part of your tool, because they are really important in the command line interface. And ensure good testability, so you can always achieve high test coverage, and also that the contributors will want to write those tests, so it's easy for everyone. And that's all from me. Thank you, everyone. I don't know if you have any questions. All right. What? Yeah, we have some. It's me who's ugly, I know. Okay.
It's outdated presentation template.
Yeah, all right, so I think we're good. Thank you.
Thank you very much, Mark. All right, so that's it for today's meetup. Thanks to Philip, thank Dennis and Marek for the presentations. Thanks to Applifting for being the host for tonight. The next meetup will be in January. We don't have a place yet, and we don't have date, and we don't have speakers. So if you want to be a speaker for the next meeting, just ping me an email or a Slack message. If your company wants to host the next meetup in January, please let me know also. And I guess that's all for me, and I'll see you all in January. Thank you very much. Sorry, one last thing. We are allowed to be here till 10, and then we have to leave. So we have like 1 hour to just chat and finish beers.
Jak to sundám, abych to nerozbil?
Tak, počkej.